So we finished off our interpretation mistakes that we want to avoid by mentioning the word extrapolation. Again, extrapolation means we use a regression line to make predictions beyond the range of our data. This is definitely something that we want to avoid. So we're going to take a look at this example here. So we'll go ahead and start by showing these images for our two different scatter plots. Data was collected showing the relationship between the age in years and height in inches for children 2 to 9 years old. That's what we see in this first image here. Right? So this first scatter plot, we see our ages from 2 to 9, and then we see the height in inches. The same regression line is superimposed on a larger data set in the second image. Will this regression line provide an accurate prediction in the larger data set? So if we look at this one, we've changed the scale on our horizontal axis, and instead of just going from 2 to 9 where our data values are, we have from 0 to 25, and our values are somewhere kind of between that 0 and 5 range, and then between that 20 and 25 range. If we look at this line does not fit our data set. Our data set starts increasing, right, in our original data set, but then it kind of tapers off, right? So will this regression line provide accurate predictions in the larger data set? We're going to say no, because our second data set is not linear, right? Our second data set increases to start with, and then it kind of tapers off, it flattens out. Right? Also, if we were to just, for instance, plug in the age of 20 into our predicted height equation, right? Our predicted height would be 31.78 plus 2.45 times 20, which gives us 80.78 inches. 80.78 inches is nearly 7 feet tall. Nearly 7 feet tall is an unrealistic prediction for your average person when we're thinking about these. So we can't extrapolate beyond our data set, right? Because our relationship may no longer be a linear relationship, right? It could be something that changes, and we could get very unrealistic predictions, as we do in this case. Right. We're going to look at one more example where we're going to see some extrapolation and how we can tell that. So we're going back to the same data set that we've been using over and over again throughout the course of this chapter, where we're looking at our height and our weight. And we are going to look at and answer a question predicting the weight of a woman who is 36 inches tall. I'm just going to switch sheets of paper here. Right. So predict the weight of a woman who is 36 inches tall. I've just gone ahead and filled in all of this because, again, it's a lot of writing, and I'd rather be able to talk to you guys rather than you focus on my hand while it's writing everything down. All right, so our predicted weight, we're going to take 36 and we're going to plug it into our regression line equation. Again, this regression line equation, this negative 442.882 plus 9.029, we looked at in the last section. We created this equation, we talked about it, we interpreted it. Now we're going to use it to make a prediction. Right? So we're going to plug 36 into this equation. But notice that if we take a look at the value of 36 and we take a look at all of the rest of our heights, that this value is way outside of our data set. Right? So 36 is not even close to being inside of our data set for our heights, because they're between 61 and 68. So we're going to see what happens then. So if we plug this into a calculator, we get a predicted weight of negative 117.838 pounds. Last time I checked, it was impossible to have a negative weight, right? So we know that this is not going to be an accurate prediction, right? So this is a negative weight, which is definitely not possible, right? That is because this is extrapolation, right? We took our data range and we tried to make a prediction that was way beyond that data range, right? So this is one of the other reasons that we want to avoid this, right? We get totally unrealistic predictions that can't quite ever possibly be real numbers, or real, in this case, a real weight. So a few questions in this section asking about extrapolation as you're going through and you're making predictions. Again, yes, we can make predictions, but we can make predictions as long as we are relatively close to the values that are within our normal data set.